So to continue, disks. So I'm working now through the model. We've dealt with the ASM instance and CSSD. Your sources for your disks. What can we call them ASM disks or disk devices, but they almost certainly aren't disks at all. What are your options? Raw disk partitions. Nothing wrong with that, except it won't work on a huge scale. In most environments, most large-scale environments, it's probably going to be fiber-attached LUNs. Now, these will be things exported from a SAN of some sort, and your system administrators will be making these available through fiber channels. And these LUNs, of course, if they are from a SAN, they may well be striped and mirrored devices. And that, in my opinion, gives you optimal performance. And with regard to security, if the SAN can do the mirroring, I personally am quite happy to let the SAN get on with it. Oracle advice is nowadays slightly different. They say don't do mirroring on the SAN, let ASM do the mirroring. There are some circumstances, such as a stretched cluster, where that is definitely required. Generally speaking, I would say it's up to you. Mirror with an ASM or mirror on the SAN. Network attached storage, wonderful, I love it because it's so easy. I don't really understand LUNs. Storage technology has moved on so much it's 20 years since I worked in system administration, and storage technology is way beyond my understanding now. But network attached storage is so simple for an ordinary DBA like me to understand. iSCSI, NFS. NFS fully supported nowadays, and with the sort of network performance you get in data centers nowadays, 10 gigahertz Ethernet or better still InfiniBand, these network attached devices perform brilliantly and they're really easy to use. I'll give you a couple of examples. So I've got a couple of demonstrations set up that use them. Depending on the disk device you're using, ASM may or may not be able to exploit the disk geometry. Clearly, if it's raw disk partitions directly attached, then the underlying hardware and geometry is fully exposed to ASM, and ASM will know which parts of the disk perform better than others. We know the theory, the outside of a disk, the read-write heads pass over more bytes per second than over the inside of the disk, and ASM can exploit that. If it's network attached, probably not, because the information isn't there. If it's fiber-attached LUNs, that will depend on the storage technology and how much information is actually exposed to the ASM. There are, however, some things to think about, and these can cause real problems. Device name persistence, particularly if you're using directly attached storage. Every time you boot the machine, Unix will identify the devices and generate device drivers. And if those device drivers pick up different names for each boot, ASM is going to have problems. Associated with that, modes and ownership. We need persistence for who owns these devices. And then again, there are, of course, platform-specific options. So to show how these things can be set up, on this one right here, this is on this database, or this server I should say, I am using directly attached devices. So within ASM, well, let me connect this. Well, SysDBA, I should be able to do most things as SysDBA. And if we look at the devices we have here, this is a very small system, of course. But here we see I've got 3 disk devices, and these are directly attached storage, dev SDB6, dev SDB7, dev SDB5. So directly attached storage in this case, and they are associated with these group numbers. Group number is the join column back to, I ran a query earlier, didn't I? The join column I ran back to the ASM disk group view. So I've got 3 devices directly attached. I've exposed the actual partitions to ASM. You would be unlikely to do this except on a very small demonstration system. An alternative approach, I suppose I should while I'm here, if we take a look at the permissions on the devices, SDB, there we see the actual drivers, the device drivers. So these devices drivers were created by Unix at boot up time as it found the devices. But then subsequently we had to set the ownership and permissions. And that I did in this case by using udev. I'll run through the detail of some udev rules later on. An alternative approach, and since I mentioned it, is NFS. NFS files. And I'm very pleased with NFS. I find it very easy to work with. I have an example. Right. For NFS in this environment, on your NFS server, what did we do? Well, I've set up a share, an NFS share, NFS shares ASM, and there I've created a bunch of files which have zero padded, just use DD to create files. And those files would typically be many gigabytes, maybe a couple of terabytes big for a large-scale environment. So your devices become files. Then on the client, I should say, if we look at the actual commands that are used, there are some platform-specific issues here and some very precise requirements for sharing these and exporting that directory from ASM devices, and the options you specify here, you need to be very careful about those, and those do need to be set up correctly. And there's also a fair bit of tuning one could do at that point. On the client side, you mount the ASM, you mount the devices. And if we look at it, a normal NFS mount, there it is. So I've mounted, oh, there's that one, the NFS shares for ASM. A normal mount, but the way you mount it is again quite important. And if we look at FS tab, there we are. That's where my NFS devices are. These options here, a fair bit of tuning, and the options have to be right. Otherwise, it isn't going to work. But that's just a one-off thing that has to be done.
John, pardon, where can the students get as part of a training class, more detail about those options and some hands-on exercises type things? Is that part of our rack grid class, or is that a separate class?
Yes, it would be. Yes, we cover that. Generally speaking, the way I configure that class, we create a cluster for each student, of course, and depending on the student's own interests, we can do the exercises either using NFS or using iSCSI, or using directly attached devices. And normally I want to discuss that with the students beforehand. And typically when I run the class, we probably have the students using one way and I would demonstrate the other way. So we do make sure in the class that we see we do see all the techniques. Great.
I'm fascinated also by the exploiting the geometry of the disk. Is that can you answer in a short answer, or is it too detailed? Is there a hotspot that can be moved to the center of the disk? Or
ASM understands we use the term hot and cold, and ASM only has a two-way distinction, hot or cold. There's no in between, and in principle, ASM becomes aware that half the disk will perform faster than the other half of the disk. And we instruct ASM to place certain files on the high-speed parts and certain files on the low-speed parts. Typically, you would want your online logs on the fastest part of the disk, because that's going to be critical for the performance. Whereas archive logs, well, they're vital, but their performance is pathetic. It doesn't really matter at all, so we put them on the lower part. And when we configure the disk group, we make ASM aware of this, and then individual file types. You don't have to specify the files individually. You can specify groups of files. Individual file types would tell ASM to store them on the fast or slow parts.
Fantastic. Thanks, John.
Now, so NFS, it's a nice way of working. If we look at the way this is set up, I'm back here with 11.2 at this point, of course. Within my ASM environments, we tell ASM where the devices are, and I'm just pointing it to all the files on that device, and it will use them as though they were disks, and my disk groups will consist of multiple files from that NFS share.